lecture that when we take two subspace W1 and W2 and we define a new subset of V which is W1 plus W2 and elements are X plus Y, where X belongs to W1 and Y belongs to W2. Then this subset will also be the subspace of V. The subspace of V. Subspace of V containing both W1 and W2. Okay, so we have two subspace W1 and W2, and we construct a new subset by the help of W1 and W2, which is X plus Y, taking X from the subspace W1 and Y from subspace W2. So this new subset of V will form the subspace of V. It means that for any subspace we can construct a new subspace, and new subspace will contain W1 plus W2 will contain W1 and it will also contain W2. We can easily see that if we take X equal to 0, then it will contain W2, and if we take Y equal to 0, it means 0 belonging to W2 because of this is a subspace. So if we take Y equal to 0, it will be X such that X belongs to W1, and this is containing W1 plus W2. Hence both W1 and W2 will contain in W1 plus W2. Okay, so we conclude that W1 and W2 contained in W1 plus W2. Now we will prove that W1 plus W2 is a subspace of V. Okay, so by the test of a subspace we will prove that this is indeed a subspace of V. What we have learned in previous lecture that if alpha beta belongs to field and x y belongs to W and V over F, we have a vector space. Then if alpha x plus beta y belonging to W, if this happens for all x y belonging to W and for all alpha beta belongs to W, then we say W is a subspace of BF, vector space. So we will use this result and we will show that W1 plus W2 is a subspace of B. Okay, so W1 plus W2, we have X plus Y, and X is in W1 and Y is in W2. Now we will show this is a subspace of B. So take two elements. Let W, take any two elements. If we take let's say P belongs to W1 plus W2 and Q belongs to W1 plus W2. We have taken any two arbitrary element, and so we have P will be of the form X plus Y. Okay, every element of W1 plus W2 is of the form X plus Y. So let's assume it is X1 plus Y1 and Q equal to X2 plus y2. Okay, here this x1 and x2 belongs to w1, and y1 and y2 is in w2. So let alpha comma beta belongs to field. Okay, we have a vector space V over the field F. So we have taken a field F and any two element from the field F. So to show, what we need to show that alpha P plus beta Q will belongs to W1 plus W2. Okay, so if we take these terms, what is these terms? Alpha and P is x1 plus y1 plus beta, and this is x2 plus y2. Okay, and this will be equal to alpha x1 plus alpha y1 plus beta x2 plus beta y2. Okay, so now we can write alpha x1 plus beta x2 plus alpha y1 plus beta y2. Combine this term and this term together, this term and this term together. Now we observe x1 comma x2 belonging to w1. Okay, and y1 and y2 belongs to w2, and since w1 is a subspace over F, so linear combination of x1 and x2 will be in w1, and linear combination of, similarly we can say that linear combination of y1 and y2 will be in w2, because w1 and w2 both are subspace of the vector space P. So we can write here alpha x1 plus beta x2 belonging to w1, also alpha y1 plus beta y2 belongs to w2. Since this term belongs to w1 and these terms belong to w2, so w1 plus w2, so it is of the form x plus y, x belonging to w1, y belonging to w2. We can write w1 and this belonging to w2, so both terms, so we can write here this belongs to w1 plus w2, and we have proved that alpha P plus beta Q belongs to w1 plus w2. This will imply w1 plus w2 is a subspace of P over F. Okay, we have proved w1 plus w2 is a subspace of vector space Pf. Now we will prove that w1 plus w2 is a subspace, and it is the smallest subspace, is the smallest subspace. A smallest subspace means what? If we have two subspace, that's the w1 and w2, and another subspace w1 plus w2, and this theorem tells that w1 plus w2 is the smallest subspace containing, we can write like here, containing w1 and w2. So it says that whenever any subspace contains w1 and w2, whenever any subspace contain w1 plus w2 have to contain w1 plus w2. So any subspace other subspace which contains W1 and W2 has to contain W1 plus W2. So we should have W. So we will prove let W be any subspace. We have taken arbitrary subspace such that W1 is in W and W2 is in W. Now need to show this is the smallest which contains W1 and W2. So this is the smallest. We have taken another subspace W. So it will contain the smallest one. So it will contain W1 plus W2. So we need to show W1 plus W2 will contain in W. Okay. So let x plus y belongs to W1 plus W2. Here we have x belongs to W1 and y belongs to W2. So x plus y belongs to W1 plus W2 and we will show x plus y belonging to W. As x belongs to W1 and W1 contain in W, we have a statement W1 containing W. Also y belongs to W2, W2 containing W. These two result shows x comma y belongs to W. Okay, because W1 containing W, so x will be in W, or similarly y will be in W. As W is a subspace, linear combination will also be in W, and we have proved that this will imply W1 plus W2 containing W. Hence, this W1 plus W2 is the smallest one which contains W1 and W2. Okay, now I'm going to give some one theorem for you to prove that which statement is a statement that intersection of any number of subspace is again a subspace of vector space P. Please prove this statement. It is very easy to prove by using the test, subspace test. Okay, how we prove this result. Okay, so you can easily prove this result. If you're not able to prove, please tell me in the comment box. I will prove in the next lecture. Okay, thank you.